Good day, everyone. We are all about getting our ACT stuff together, working on Project 5 and dealing with rational functions. In this presentation, I will be discussing with you the data, this week information, ACT, Project 5, and rational functions. The data. This is the data from the ANET that we have taken in January. I know, y'all, the ANET was difficult because we took a 2 week vacation and then we had one, at most two class periods if you was A day to prepare for this ANET. All right. So here's our data. So this is the overall performance. The yellow represents us. The gray represents the district. So look here. Here we are, and here the district are. Looks like we're doing good. We're handling our business. We use street smarts, common sense, something that they don't consider people who go to the dirty eye is able to do. You was able to demonstrate that skill. Now, I know from the first 9 weeks we have 41, we dropped to 21, but that was to be expected because of the Christmas break and the stuff that you guys went through last semester, such as being tested before we couldn't review and basically being stuck on Math Nation for a while. But I want you guys to give yourselves a applause because of the fact that they keep counting us out and keep thinking we're not able or capable of. But here we are for the second 9 weeks in a row, happen to outdid a lot of schools. So we should congratulate ourselves and just be happy about it because we did that. We did that. All right. So let me explain the data even further. Again, despite the continuous disadvantage, we pulled another win. Not having the technology that we actually need, the smart board not always consistently working so we can do the jobs that we are need to do. But one thing, they call us hood rats. Me included, they call us all hood rats. But one thing they don't realize about us, hood people, we think on our feet. We quit to think on our feet. We can reason well on paper, that common sense rationale, because you guys achieved that yourselves. You did that. Everyone will receive a small bonus point added to their grades. So it's not as a lot as you think. It's not like 100 points or anything like that. Just a little. And I know that no one's not celebrating our hard work, but we should celebrate it. And I'm celebrating in terms of giving you those points. However, do not think that I'm gonna just let up on you. That's not gonna happen. Because you got the ACT to contend with, the thing that I'm most interested in. All right. Also, I know teachers like to say, "Oh, this is a F school," blah 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 blah, because you guys not doing this, you guys not doing that. Don't pay attention to that talk. I don't keep pay attention to it. And I'm a teacher at Struma. I don't care. I just go to work, do my job, and go home. That's it. I ain't care about nothing else. You know? I mean, if you're gonna have behavior issues, you already know how I operate. Just I handle you guys. So again, you guys are capable. You guys could deliver so much. Don't let people tell you otherwise. You're going to have people to do so, but don't listen to them, ignore them because they don't know you and what you can deliver. Also, and last, we cannot slack off because we got ACT stuff to deal with. All right. Now let's talk about the ACT. It can make Algebra 2 easy, like the Algebra 2 final. Can make the end of the Algebra 2 year be an easy walkthrough. Remember, our 18 will excuse you from all quizzes and tests, and that includes my final. So far, I have 2 students who are excused from any quiz and test, and then they don't have to take a final. However, with the 18, you are still responsible for other assignments. A 21 will excuse you from all tests, quiz, and homework. All right? You are responsible for projects and other classwork. That's for both 18 and 21. The only difference is if you got 18, you still got homework to deal with. All right, last at least, seniors are required to do only projects, classwork, quiz, but are excused from my tests and must deal with ANET and ACT. Well, that's the perk of being a senior, you know? So, as long as you get my projects together and you can explain well, you're good to go. And that's again for seniors. And it could be for juniors and sophomores if they scored that 18 I need. Or 21 if you want to get excused for more things. This week announcements. What's good? What's the tea? Project 4 should be completed by now. You should be pretty much done with it. Remember my 3-day policy. If it's not done on the due date, it's day 1 late. All right? And after 3 days, if it's not turned in, I don't grade your project. I'm done. We will be busy until we finish ACT in March. Hear me? We are going to be busy all the way through March. So February, you are going to be working real hard. All right? Optional assignments will be soon open to improve grades, but not many though. So it's not like I'm giving you a whole lot of work. I mean, a whole lot of bonus opportunities. I give them to you, but there'll be 4 in between. Watch the videos. A quiz may occur from them. Participation logs will help you out in Project 5. And then we're going to have to do more of our math etiquette. Because I see as we guys are doing the class work, some of you guys too busy. Is this right? We're going to fix that. I don't want that. I want you to think for yourself first. Because you know we're going to always go over the class. So just put what you got to know on the paper and just go with it from there. All right? And again, and you ask me, if this right, I won't respond to you. Because at this point in the game, you guys are a little too old for that. Just show what you know, and we help you figure out the rest. And remember, with mathematics, you're going to get it wrong before you get it right. I need for you guys to get used to that concept. There's no, oh, I got to get right, I got to get it right. You're going to get it wrong first before you get it right. And that's the reason why we're taking that ACT. We're going to get it wrong first. So when we take the real one in March, we're going to be right. All right, quiz. So the next quiz that's coming up is going to be the precise definition of mathematics, in addition to some other things I may include. So this little quiz, it's a short quiz. It's not even worth a whole lot of points. It's not worth 250. Now unless I include it to a 250 quiz. I need for you to watch the precise definition of mathematics video that is in my Google Classroom. I mean in my YouTube account. So when you go click on the video or watch a video of mine. Just go to my video session, scroll down and find that video and watch it. Please prepare for it. Commit it to memory. Your quiz for this is going to be like a short 20 minutes. I may make you take it on the 9th through the 10th. All right. And this is a May situation. I may make it a standalone quiz or I may include it to other things. Project 5 help for exponential and logarithmic functions. So look, to start, let me ask you these series of questions. And start jotting it down on paper and pencil and paper to put your notes together. What do you know about exponents before learning about it in Algebra 2? What do you know about exponents before? So go back from we first heard the word exponent, or go back to Algebra 1. I want you to pull some knowledge before you met me into, your paper. So start jotting down what you have known about beforehand. What have you learned about exponents from Algebra 2? So from what I have taught you, now I need for you to jot some notes down on that too. What is hard about exponents and or exponential functions? I need for you to, when I hand you your quiz back, I need for you to just look at that and kind of just critique it from there. What do you know about logarithms from Algebra 2? What did I teach you about logarithms? What's so hard about logarithms functions? Your next quiz is going to incorporate that. I know I didn't, the last quiz we took, I didn't put that in there. All right? So here's the precise definition of mathematics. I'm going to show you how to paraphrase, put things in your words. So the precise definition of mathematics is the technique to explain, understand, and manage reality specifically by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environments. That's the precise definition of mathematics. Now, if you ask Mr. Howard this question, how will I paraphrase it? How will I say it in my own words of the precise definition of mathematics? So what I'm saying is, can you have your own meaning that matches the original meaning? So let's do it. In Mr. Howard's words, the precise definition of mathematics is to deal with reality by methods of explaining, comprehension, decoding, counting, to measure, organize, make inferences, and creating models from patterns seen in day-to-day life. That is my definition. And you see how closely it relates to the other one? Because that's what you want. Because when I'm saying put in your own words, they have to have the same meaning, but different words. So if you don't know how to do this, just take the original precise definition of mathematics and look up each word and kind of just, find some synonyms and just put in your own words. But again, my definition in my words is exactly the same meaning as the precise definition of mathematics, and that's what I'll be asking you to do. So on your quiz with the precise definition of mathematics, again, you won't have notes for it. So put it in, so know the definition and then be able to put in your own words. And this is going to help you with Project 5. Okay, so when we research these professions by exponentials and stuff like that, how does a person, this is an example, how does a person satisfy the definition? Just a day-to-day person Don't pay attention to the title. Just pay attention to them. So, a day-to-day person explains, understand, manage reality by counting, measuring, classifying, and to a certain level, infer, make inferences. For example, a mother satisfies this definition because she managed reality, in particular by counting, and she measures. When she's dealing with children, she measures, how much money is this, how much money is that, you know. She classifying which bill is more, it costs more, and how to rationalize her paycheck. Make inferences, meaning that if she missed days, she don't get a paycheck. So that's just how that works. And then you kid self how the precise definition of mathematics simply by counting and measuring how much time you got left before class ends. All right, to get started. In the event that the smartboard is not working for us, I have attached a video posted to assist you on Project 5. In Google Classroom, this video right here is going to be posted next to Project 5, and you're going to have access to that. All right, rational functions. Meh, they're okay. They're not hard. It's just knowing how to work with rational functions and rational stuff. So review. I didn't know a rational number with the letter Q. And a rational number is what? A rational number Q can be written as a quotient of integers such that P and Q and that little symbol you see that looks like a triangle, that's the mathematical symbol for and. And Q, the denominator, cannot equal 0. Why is that? Below I gave you 3 rational numbers to use. Put them in your calculator and see what happens. 5 divided by 0 is undefined, or it says error in your calculator. 1 divided by 0 is an error, undefined. 50 divided by 0 is also error, undefined. So anything divided by 0 is going to give you what? Undefined error. Anything divided by 0 is an error. Anything divided by 0 is an error. Anything divided by 0 is an error. Now let's go back to our elementary days, back before a fraction was called a rational number. So basically operations of fractions. So let's do the adder. So we know to do this, we have to make those denominators common. Multiplying the left side all by 4 and multiplying the right side all by 3. And when we do that, we get the following. 4/12 plus 3/12, 7/12. Alright, so let's do the second one. 1/2 minus 1/3. Same procedure as you did with the addition. Multiply the left all by 3 and multiply the right all by 2. So 3/6 minus 2/6. 1/6. So let's do multiplication. So with multiplication, usually you can multiply across, but that's a certain case where that's not going to happen. You see those 2's? How I got them both in red? I have a 2 in the denominator and then a 2 in the numerator in the other one. Well, because they both have the same exact number, you could cancel those out. simply by dividing them out by, well, 2. So 2 divided by 2 in the denominator and 2 divided by 2 in the numerator of the second rational number. And when you do that, you get 1 over 1 times 1/3. Now in this case, multiply across and you should get 1/3. So let's do the division. So we know division is keep, change, reciprocate. So keep 1/3, change division to multiplication, flip 2 nines into 9 halves. And that's what I did here. Here, the 3 in the denominator and the 9 in the numerator, they both have the greatest common factor of 3. So when that happens, you can just divide them out by 3. 3 divided by 3, 9 divided by 3. And when you do that, you should get 1 over 1 times 3 halves, and just multiply across, which gives you 3 halves. And this is going to come essential when you simplify rational expressions. Let's do some basic simplification. All right. So let's simplify the first one. To do that, you got to use division. 25 divided by 5, it gives you 5. And then with the x squared divided by x, using your law of exponents, which again, project 5, 2 minus 1 equals x. So our final answer we put together is just going to be 5x. And I'll put the dot because that's the answer. I'm not even wanting you guys to even go no further with it. That's it. Now the second one is going to be done a little bit differently. Well, it's the same, but your outcome is going to be slightly different. So 25 divided by 45, which when you simplify that, it's going to be 5 nines. And you got that from the greatest common factor of 25 and 49. Because 5 times 5 is 25, and 5 times 9 being 49. And that's how you get that. Now again, using your law of exponents, x cubed minus 5 give you x to the negative square. And we know, using your law of exponents, still, help me out with project 5, you could rewrite that negative exponent as x squared. All right. So let's do this last one. The last one's a little tricky. Go back to your factoring. Remember those cases we did? So let's go back to it. So where two numbers for the numerator, where two numbers multiply together gives you 6, but the same two numbers gives you 5. You add them. And you're going to ask yourself the same questions for the denominator. Where two numbers multiply together gives you 2, but when you add them together, gives you 3. And that's going to be, for the numerator, 2 times 3 is 6, but 3 plus 2 is 5. And if you use your formula method, you get back to the original. In the denominator, 2 times 1 is 2, 2 plus 1 is 3. And you FOIL that out, and you should get back to the original. Now, you see those 2's, x plus 2, in the numerator and the denominator, that factor? Guess what? just like we did with multiplication, they could cancel out. But there's going to be a twist to that too. That too is going to matter. You are left with, after you cancel out that x plus 2 factor, you're going to be left with x plus 3 over x plus 1. Now, the x plus 2, as we did beforehand, you have to solve that. What I mean by is this: x plus 2 equals 0. And when you solve for x, x equals negative 2. And we call that the point of discontinuity or the hole. So when you graph this, you are essentially looking for when the graph becomes undefined. The hole, it becomes undefined at negative 2. Also, for this 1, it becomes undefined at negative 1. Because going back to your rules of a fraction, rational number, P over Q, what can never happen? Q can never equal 0. Can never happen. So when you're looking for undefined, you're looking for things that make the denominator cancel out. Become undefined. Again, you could just plug this into decimals and you will see exactly what I'm talking about. All right? Cool. And you got any other questions, talk to me about. I could help you out. All right. So here's a little piece of information to help you guys understand holes or points of discontinuity. It's possible to have holes in the graph of a rational function. By putting the rational function into the lowest terms, factor the numerator and the denominator. If there's the same factor in the numerator and the denominator, then there's a hole, like we did with this function here. Set this factor to 0, then solve. The solution is the x value of the hole. And then you gotta simplify the rational function simply by crossing out the factor that is in both numerator and the denominator. Put the x value of the hole and simplify the rational function. This gives you the y value of the hole, just like we did. So again, x plus 2 is both of those. So when you set it to 0, solve for x, you're going to get negative 2. But that's cancel out, so negative 2 is going to be my hole. And again, my point of discontinuity, what's going to make my function undefined when I'm left with x plus 2, this right here. Because if I plug in negative 1 plus 1, x plus 2, my denominator is going to become 0, and that I can never have. Right, guys, for these problems, all you really have to do is just use your operations of rational numbers that we did in the previous examples. So from the addition, all you have to do is just find your least common multiples and just add across. And if you need any further explanation, just send a message to me. I will gladly do that. All right, for multiplication, all you have to do is just see what could be canceled out, which we know we have a 10 in the denominator, 10 in the numerator, so just divide both by 10, and shabam. The only thing we gotta do is just multiply across, and we are done. All right, for the division piece, I'm gonna do this a little bit different because you keep change reciprocate. Instead of me looking for common factors to cancel out, I'm gonna multiply them across like usual, and then simplify it. So with multiplication and division, the methods are the same with the exception of the division keep change reciprocate. So let's see the division. So our keep change reciprocated. I realized I could do a lot of canceling stuff out because if I go here to 10 in the denominator right here, they had common factors, and all these had common factors that they could cancel out too. So for the space of time, I'm going to multiply them across instead of canceling out like I did in the previous multiplication problem. So I multiply across just that. And now from there, I could just simplify. So you just know you got to simplify, but it doesn't matter which order you go into the simplify. You could simplify as you go, or you could just simplify at the end, and you get that, and that's it. All right. Rational functions. So, rational functions, they got the following characteristics. They have a domain of 0 to infinity. They also have a vertical asymptote of 0. So they got range of 0 to infinity, but also a horizontal asymptote. So yeah, this have both horizontal and vertical asymptote. Because you think about it, it does kind of look like a logarithmic function. It does look like an exponential function. Because we know that exponential functions has a horizontal asymptote, and we know that logarithmic have vertical asymptote. And these graphs definitely do not have any intercepts. Transformations of rational functions. It's easy, and you guys do well on this. So K, tells you up and down, H is left and right, but pay attention to H because H is hard. H telling you left when it's positive, the transformation, and when it's right, it's negative. So you gotta be careful to know that. All right. And it's just simple. So last thing I want to ask you for is how does the transformation affect the characteristics of the original function f of x? All right. And then after you finish one, talk to me about it, and then talk to me about two, and then talk to me about three. All right. And for those who are doing this online, just send me a message about this part. All right. Homework is going to be Math Nation. Just follow them because they should cover asymptotes. If they don't cover it, I will cover it in class.